Good morning, good afternoon, good evening. I'm Ian Tabor, and I have actually previously been asked to attend ROOTCON and bring my PDO car in a box. However, you'll see further on in this presentation that logistically that would be impossible to bring this to the Philippines. However, it is my honor in presenting to you today my talk from an IVI in a box to a car in a box, which will show you how I built my car in a box. Hopefully sometime in the future when the world gets back to normal, I will get out to the Philippines. If not, I'm sure I'll come across Jay at some point in the future. So where should we begin? Who am I? Well, you could say I'm the ultimate car hacker. 15 years ago now, I built this Tiger Supercat, which is a Lotus 7S car. You get in a kit form. It's based on the running gear of a rear-wheel drive 1990 Sierra. It has engine out of a 2004 Ford Focus. Has about 170-ish horsepower and weighs about 700 kilos, so it goes pretty quick and it's fun to drive. Not exactly the most practical thing in the world, but ho-hum. But it is completely different to the car I hacked, in that it only has 3 ECUs. Of those 3 ECUs, I built 2 of them. One of them is the Mega Squirt ECU, which controls the spark and injection on the engine, and the other is the little thing you can see in the top right-hand corner, which is a Arduino Mega based GPS data logger, which actually does have CAN bus on it to read data from the Mega Squirt ECU. So that is completely different to what I hacked. There's a little disclaimer down the bottom there. If you are going to hack a vehicle, you do it at your own risk. The reason I say this is because previously I have actually bricked my car. A few years ago now, I had a Jag. I was playing around with one of my own built pieces of hardware, plugged it into the OBD2 port, turned the ignition on. It lit up like a Christmas tree, and then come up with the error message, can't find gearbox, which is fun. Okay, so unplug the cable, turn it off, turn it back on, still can't find gearbox. Okay, next step, let's go and get the diagnostic tool. Diagnostic tool said, yep, short on bus, couldn't reset the gearbox. What do I do next? So at that point, it was get the spanner out, disconnect the battery, disconnect the battery for about 30 seconds, plugged it back in, got back in the car, turned it on, still can't find gearbox. Yeah, at that point, I was getting very, very worried. 40 grand car, not fun to ring them up, say, by the way, I think I bricked the car. So the last thing was to disconnect the battery for about 20 minutes, left it off for 20 minutes, plugged it back in, went back to it, got in, turned it on, no error messages, no lights, found the gearbox, started okay. At the time, it was about 11 o'clock at night, so I didn't actually want to go and drive anywhere. But next morning, got in it, went to pull away, drove out the driveway where I live, and it had forgotten how to change gear because the Jag that I had the XE gearbox, 8-speed, which learns your driving style. It took me, the vehicle, 3.5 weeks to learn how to change gear again properly to my normal driving style. Stupid thing was, 6 weeks later, I did exactly the same thing. So if you ever come across a car hacker that hasn't bricked a car, they've either not been trying enough or they're lying. So on to my car hacking history. The car in question I will tell you about in a second. I wrote up how I did it, how I hacked it, and then I presented about that in 2018 at DC 4420, B-Sides London Rookie Track, and DEF CON 26 Car Hacking Village. After that, I was invited to Bug Crowd's live Bug Bash in 2018, which is probably where I first met Jay from ROOTCON, because he works at Bug Crowd. At that event, myself and another couple of people found a major vulnerability in one of the vehicles, got a payout of 5 figures between the 3 of us, which actually funded the car in the box. I then went back to the bug bash in 2019, didn't quite find as much there because they ruled my normal attack vector out of scope because anyone can attack the canvas. DEFCON 27 last year, I did a bug crowd car hacking panel with Cyber Gibbons and Spectres. I also presented HackerOne at Auto Isaac on a car hacking vulnerability disclosure policy panel. And for my sins now, I run the car hacking village in the UK. 2019, we did quite a few events. I think I did about 14 in total, including the ones shown on the screen there. 2020, the plan was to do a bit of a European tour, and then COVID happened, which has meant I've actually done some other global conferences, which I wouldn't have probably done if I had been in real life. But I did miss out on going to Dublin, Stuttgart, Brussels, London, Liverpool, and SteelCon are all cancelled as well. Thank you very much, COVID, but better to be safe than sorry. So I have actually done this talk at quite a few conferences before, but yep. I've also been invited to go to many other conferences around the world with my car in a box. For example, OzSecCon in Australia, a conference over in Brazil, NullCon in India. I was asked to go to Egypt to take it to B-sides over there. But logistically, it is a bit of a nightmare. So onto the car in question. In 2015, many years ago now, I bought this brand new Citroen DS5 1955 limited edition. It had all the bells and whistles, all the toys, absolutely everything, including a 7-inch touchscreen in the center of the dashboard, which would allow you to surf the internet from your vehicle if you wanted to, if you tethered over Wi-Fi or Bluetooth to your mobile phone. Why you'd want to do it, I don't know, because the UI is absolutely useless and it's really slow browser, but the option was there. While doing a bit of traveling up and down the country, I got a bit bored one day and I decided to run Nmap against my head unit while tethered to it from my mobile phone and found 4 ports available. 23 Telnet, 111, which is NFS or RPC, 3333 and 20,000. I've subsequently been told that 20,000 is DMP3, which is an industrial control system protocol, which potentially will allow direct access to the CAN bus, but trying to find someone that knows how to actually craft a DMP3 packet to see whether it has direct access to the CAN bus is getting a bit difficult, but I have got some information, but I've not actually got around to using it yet. So it had Telnet open. So what do? Telnet to the head unit. What happened next? Full access to the file system. So in the center of console, there is a USB port. You can plug into that USB port. That will allow you to copy files off if you wish. When you do explore the file system and copy some files off, there are some SQL-like databases that include your GPS history, your phone book, and your phone history. Thank you very much. Personal data, yep, great. So I found out this and sort of parked it for a bit until I decided to sell the vehicle. At the point I decided to sell the vehicle, it was fair game. Let's see what else I can do. I then later found out by looking through VxWorks command reference that you didn't actually have to copy it to the USB port. What you could do was map a path to an FTP server and then copy your files one by one from the head unit over Wi-Fi onto the FTP server. Wonderful, great. So I wrote my findings up, sent it to Peugeot Citroen, and then we're like, well, we don't get it. It's up to the user to secure their Wi-Fi. It's like, I'm not saying the Wi-Fi is insecure. I'm saying you shouldn't really have Telnet running. Just like, I still don't see the problem, but whatever. So pose the situation to them. Your mobile phone's dead. You want to go to the cinema. You want to find out what time the things are on. So you pull your car into McDonald's car park, tether onto McDonald's car park. While you're in there, some other scrote in McDonald's car park and then run an nmap across the wireless LAN, find port 23 open. If they know what they're doing, they can then find the files, copy them off. They now know where you live. You're away from home, and they can go rob you. And they were like, ooh, that's a bad idea. I know what we'll do. The suggestion is disable Wi-Fi, which is wonderful. However, the same hack is available over the Bluetooth personal area network stack. The only saving grace on the actual device is that every time you switch the vehicle on, you had to manually go in and say tether, either over Wi-Fi or Bluetooth. It didn't do it automatically. I'm sure there must be a way to make it do it automatically, but I haven't worked out how to do it yet. I did point out to the Peugeot Citroën that the French president gets driven around in one of these vehicles, very similar. And it might be a matter of French national security, and they laughed at me. It was like, yeah, great, wonderful. Okay, so I sold the car, and I thought we can still do something with this. What I'll do is I'll go and buy a head unit from the scrapyard. So I went on eBay, found a head unit off a DS3, went up to the scrapyard, went to collect it, and had to pay for it, and asked, could I have the cables? At that point, they went, well, it's going in the DS3. You don't need the cables. It's like, no, it's actually going in my kit car. Couldn't explain to them I was going to hack it, but so they reluctantly got me the cables that were needed to connect it all together and connect it to the outside world. One of them wasn't actually from the same vehicle, but it fits and it would work. But at that point, they then said, no warranty, can't bring it back because you're not putting it in the original car and you'll never get it working. So challenge accepted. As you can see on the screen here, you have quite a few parts of what would normally be either on or under the dashboard. To get the head unit working outside of the car, you can't just put 12 volts on it anymore and flick a switch. What you need is a CAN bus message to say wake up. Actually, you need quite a few CAN bus messages to say wake up. But so I had to then purchase the underdash wiring loom, the ignition key, the body control module, and the engine ECU together because they are coded, because I was planning potentially to build a car in a box in the future. Those are the only bits that actually need to be coded together. You then need the steering column switches, the instrument cluster, some other switches, and a nice 12-volt power supply. Plug it all together and you get the head unit working. Wonderful. At that point, I'd probably spent about £500. So the challenge was, could I get the head unit working without the rest of the bits that are shown there? So I did got my old Arduino with a CAN shield out, did some sniffing, did some replay, managed to find out that there are 5 messages that are required to tell the head unit to come on. So at that point, I then got myself a nice little case, put the head unit in the case, and then I can then take that to conferences and show people, this is how I hack my head unit, this is how you do it. You can do it too if you really want to, and you can see if you can go any further with that. You probably can't see it, but on top of the head unit here, there is the Wi-Fi symbol that says it contains Wi-Fi. Yes, it did when I first bought it. Problem was someone had disabled it somewhere, so it wasn't actually working, so you could only do the hack over Bluetooth. Hack over Bluetooth is slightly more involved because you have to do personal area network and it's a pain. However, I did find a strange Russian website that actually tells you how to play with the SQLite files and modify the settings inside the head unit to allow the Wi-Fi to work. And as you can see there, the Wi-Fi is now available as well as the Bluetooth. All these other components were actually from a Peugeot 208, not a DS3. They're made by the same manufacturer. They are sort of the same vehicle, but not quite. The DS3 is actually based on a Peugeot 207 infrastructure, I believe, and not a Peugeot 208, but the same head unit was sold across the range in those other vehicles as well. So after coming back from the bug bash with that nice share of the 5-figure sum. I had some money spare. I was off work at the time, so I decided to build a car in a box, or a car on a bench to start with. Here is the inspiration, which is Grim Cyber's 3PO. You've probably seen it at DEF CON or on some of the videos from DEF CON. It is all of the works, all of the electronics from a 2012 Ford Focus. However, there is a caveat. It doesn't think it's a fully working car. My plan is to make it think it's a fully working car. Engine rotates, the wheels rotate, and all of the dials actually will work. They do. I'll come on to that. So at that point, it was a case of let's get all the other bits that make it think it's a car. So we have on this screen here the steering rack ECU and steering rack. That's because it's got electronic power steering, so it will need a CAN bus message to tell it to turn the power steering on. Potentially, some of these vehicles would actually do actually have park assist, so the steering can actually operate itself. Not worked out those messages yet. What I want to do is find one with park assist and then record what happens while it's parking to see whether I can actually get my car in the box to do the same thing. So you've also got the throttle body, the main fuse box, which also potentially has an ECU in it. Engine ECU I already had, ABS ECU I had to purchase. None of these parts, extra parts, had to come from a specific vehicle because they're not really coded to the vehicle, in that they will still work even though they're from a different vehicle. There are some things that you may have to change in the body control module to tell it which version of the power steering, but I didn't have too many problems. Okay, in the top right, we've got the instrument cluster and the steering switch cluster. Bottom right, you've got a laptop that's powered by Steam, I think, which runs the Peugeot diagnostic software. And when I first plugged all this in together, I think there was 3,500 error messages from missing ECUs, missing codes, missing sensors, and absolutely everything. Yeah, it was fun. I think I've still got about 50 errors on the vehicle, but ho hum, it's never going to go down the road again. It's not even a vehicle. It was purchased from parts from eBay, etc. So if you want to make a car in a box, you then need the wiring diagram. This is the wiring diagram for the ECU for my Mega Squirt. As you can see, it's a DB37, which has 37 pins, 26 are in use, 6 are ground. It's not exactly a complicated engine because it's batch injection, wasted spark, single O2 sensor, coolant sensor, air temperature sensor, fuel pump, crank sensor, fuel relay, etc. But it's not exactly anything to Mickey Mouse. But that is nothing compared to if you have a look at the wiring diagram for the Peugeot 208. The Peugeot 208 in question is a 1 litre 3-cylinder with sequential injection, sequential ignition, dual variable valve timing. So it's got 2 solenoids and 2 cam sensors. It's got dual O2 sensors. It's got temperature sensors. It's got a MAF sensor. It's got absolutely everything you can probably even think about. There are 3 connectors on the ECU, 2 53-way connectors and a 32-way connector. So there's 138 possible pins. Not all of them are used, but it does get a bit busy. One of the looms I actually had to build myself. The other 2, one came from the inside of the car, one came from under the bonnet. But you can get the connectors, and they're not cheap, and you have to buy the connector, the shielding that goes on top, the pins, the correct tool to crimp the pins, because they're a pain. But yeah, so first things first, when making a car think the engine's working, is you've got to make it think the engine is working. So to actually fool the engine ECU, you need crank and cam signals. If you know anything about the Peugeot engine, it has a 60-2 sensor on the back of the crankshaft somewhere. I think it's on the back of the flywheel, in which there's 60 holes in the flywheel, equally spaced, and there are 2 missing holes, so 58 holes, but yeah, in a certain space, so it knows where it is in the cycle. Because it has dual variable valve timing, there is also 2 cam sensors, one of which is pointing here and one of which is pointing here. As you can see, there is a profile on the end of that cam and that cam that are very similar but slightly out of phase. So what I had to do was work out what that would look like in a graph, and then I had to find a bit of software that could actually simulate these signals. So I found a bit of software called ArduStim, which you can program an Arduino Nano, Uno, or anything like that, and it will generate the signal. D0 here is the crank sensor, D1 is the inlet sensor, D2 is the exhaust cam sensor. The board in the bottom right corner there is the populated board I have subsequently made to allow you to spoof those signals on an ECU. If you would like one, message me somehow and I will send you them. I've got loads at the moment. If you want to try and do that, it will work. There are both surface mount and through hole for the small transistors and resistors, but there's also a massive transistor in there for the other ABS simulator that I have built. So that is that. The next sensor you would like to fall is the lambda sensor. The lambda sensor detects how much burnt or unburnt fuel is in the exhaust. This vehicle has 2 of them. What happens is there is a AC wave on a DC offset that basically floats between going lean, going rich, and this 555 timer circuit on the screen here is the one I used, and it does work, and it clears the errors on the dashboard that say the lambda sensor is not working. However, there's 2 parts to a lambda sensor. The other part of a lambda sensor is the heater circuit, which would normally draw about an amp. So what you have to do is wire up a massive 50-watt-ish resistor across the heater circuit, both heater circuits, and I have done that, and they're on the back of my car in the box. And every time I have this do this presentation in real life, I always tell people, stay away from them, they get pretty hot, and someone at the end of the day will come over to me and go, yes, they do get pretty hot. But yeah, great, whoops, you shouldn't really be touching that. Some of the other sensors I had to fall were the fuel gauge. That was done by using a potentiometer. The coolant temperature sensor was also done by using a potentiometer. The final one of the things that was simulated within the car in the box is the ABS and wheel speed simulator. This was actually quite hard. I tried originally to do it with just logic and not actually have to have a spinning motor. But when I probed the signal on my oscilloscope for the wheel speed sensor, it's varying amplitude and varying frequency depending on how fast the wheel's going around, and it's not that easy to do. So I cheated, and in the middle of this box here, there is a large motor, which is probably a bit too large, but that is attached to a shaft. On that shaft is a plastic disc. Around that plastic disc is the reluctor wheel that would normally be on your axle on one of the 4 corners of your vehicle. Around that reluctor wheel, you can see there are 4 sensors. You only actually need 2 of them, but I put all 4 in because why not? It gives me a bit of redundancy. When I only had 2, if one of them went wrong, you then have to get the steam-powered laptop out, which I didn't always take with me to conferences, and that would mean you couldn't actually use it. as you can see, there is another potentiometer on here. That variable, that varies the speed of the motor by using pulse width modulation, which then spins the reluctor wheel faster in front of the sensors. That then, there is a CAN bus adapter on here, which then reads from the CAN bus the speedo speed and then tries to match what you want the speed to be to what the actual speed is on the speedo. It's very, 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 very interesting, because what happens is when you have it trying to match the speed, it will go flying past it because of inertia, and then it will realize, oh no, I've got to slow down, then it will go flying past it in the other direction, and then it realizes it has to speed up, and then it will eventually settle down and get vaguely near the speed you actually want it. However, it makes a very, very strange whining noise, but you'll see that in a minute with one of the videos. So onto the CAN bus networks. Within the car in the box, there are actually 4 CAN bus networks. This is the same as if it was in PDO. The reason why it's called PDO is P for Peugeot and DO is 208 in hex. So your normal OBD2 port is in the bottom left-hand corner here. There is a CAN bus, high-speed CAN bus that goes from there to the body control module, the main fuse box, ABS ESP, ECU, power steering, and engine ECU. So that's all 500K, and that you should be able to use through the OBD2 port. The body control module does actually work as a sort of gateway, so you've not got direct access to those other ECUs, and because it's not sold into the American market, it doesn't conform to any of the UDS standards. So you can send a request for UDS of any variable you like, and it will completely ignore it, which is great when someone's doing virtual hacking and they try to do it and then don't realize, and you try and tell them that it won't work and they say go away. There is a second CAN bus here in yellow and green. That's a low speed 125K CAN bus. That one is for it goes from body control module, again, gateway, to steering control ECU and the airbag ECU. I have not included the airbag ECU in the car in the box because I don't really want someone playing around and setting an airbag off in a conference and then having to fill a form in. But potentially I could put the airbag ECU in and you could actually then play around with that. At the end here, there is an additional OBD2 port. That is so that you can interact with that bus without actually having to, just makes it easier to show people hacks and things. The third bus in blue and other blue goes from body control module, the instrument cluster, the matrix within the instrument cluster, which is actually a completely separate ECU. That's the one that shows you your GPS arrows and things, and speeds and things when you're using GPS. It also goes to the IVI. I have subsequently installed into the car in the box, but not quite got it working, a rear parking sensor. I'm still working on that one, so that's not actually on the picture just yet. Again, this second low-speed bus has an extra OBD2 port at the end, so you can interact with that bus and make it do silly things like disco mode. The final fourth CAN bus is actually between the IVI screen and the IVI itself. I believe that's for the touch screen. Why invent something different? Why not just use CAN? I've not really had to play with those messages because the cable only goes between those 2 points and doesn't go anywhere else. So I really played with that. But yes, so here is my car in the box in stay-at-home mode, which is pretty much how it's been all year this year, apart from some of the online cons where I've had it available remotely. And yes, that is bigger in you on the left. Here is my car in the box in the boot of my car. This is the slightly bigger RAV4 that I have. The actual car in the box was designed to go in the tail gate of my Jaguar XE that I had, in that it was the only thing that would fit in the boot, and that's about it. When purchasing this car, I had to actually take a tape measure with me just to make sure that this would actually fit in the boot without having to have the seat down. Fun, yes. So next two pictures are the ABS simulator on the left and the head unit in the box on the right. Again, you can see the little Wi-Fi logo just here that says it's got Wi-Fi. At this point in time, the Wi-Fi wasn't actually working, but I've now subsequently got it working. Here is the car in the box itself. Most of the main controls are on the right. Most of the big ECUs are on the left. So you have your steering controls, your ignition key, which actually does work. So you have to crank it to get the engine ECU to start and the simulators to start working. There is a little fuel pump potentiometer there. There's the rear windscreen washer. Original plan for that was to have a whiskey bottle attached to it, and if you could get it to spit out whiskey on the front or rear windscreen, you got to drink what came out of it. Minor problem with that, alcohol in cars is frowned upon, and the other minor problem is every time you press that button, it does about half a litre, so it would get very expensive very quickly to actually put some decent whiskey in there, and someone will get very drunk. The plan was if you could get the whiskey out without pressing the button, you got to drink it. There's the two additional OBD2 ports. On the left-hand side, we've got the body control module at the bottom with lots of cables coming out of it. Steering rack, which does actually get slightly lighter when you actually turn the thing on. You can actually rotate it and move the rack left to right. Left-hand side, there's the ABS ECU. In the middle is the main fuse box and a loaded cable underneath it because I didn't want to shorten it. This little blue box on the left is the ROOTCON device. There is some switches on the top that can actually disable the crank and cam sensors. Don't normally use them that often, but the little dial there will actually allow you to vary the revs on the engine ECU. Above that is a piece of trunking that has some LEDs in. The bottom LEDs show the indication of the injectors firing. The top LEDs show the indication of the coils firing for the spark plugs. At the top of that said piece of trunking, there is the variable resistor that actually controls the coolant temperature gauge on the dashboard. So if you play with it, it does actually go up and down very, very slowly. Top left-hand corner, there is the throttle body. When you plug the thing in, it will actually work. So when you push on the accelerator, the throttle body will open accordingly. It is drive-by-wire, so there are situations where if the revs are really high and you try and floor it, it will not open the throttle body, basically because there's no sensor coming off the map sensor. So that little blue box next to that is the O2 simulator using the 2555 circuit. Behind the back of the board there is the two heater circuits. There's the engine ECU with a couple of oil pressure and water temperature sensors. You've then got the clutch and brake switches because they are used for, the clutch switch is used to disable the cruise control and detect gear change, etc. And the brake switch is used for the flashing the brakes, etc. But here you can see it's actually cable tied down because I've put a switch in parallel with it next to it here. There is a white better board here. That is actually, yes, a cutting board with some holes drilled in the back and some suitably coloured LEDs behind to actually show the indicators front and rear of a vehicle. I'll show you that in a second. Underneath there is some very large resistors. They are there for the purposes of fooling the ECU in thinking the bulbs are incandescent, not LEDs, because if you don't, they'll flash fast because it thinks one of the bulbs is dead. So onto a little video. Here is a little video of the rev counter going up and down, which is the ROOTCON being tweaked. Now you can hear the whining of the ABS simulator motor. it's getting slightly faster. It's doing 70 mile an hour, but going nowhere. It's doing 90 mile an hour. It's now doing 143 mile an hour. If you've ever been a Peugeot 208, I don't think you'd ever get it to 143 mile an hour. It would have rattled itself to bits first, but that shows you how you can play with the ECU simulators and affect what's happening. On to the next slide. Hang on. This here is the NanoCam adapter. I made this in 2018 as my business card, just to get people into remembering who I am, really. But it's actually a PCB that will allow you to build a cheap, probably sub $5 CAN adapter, so that you can get into some basic car hacking. On one side is the Arduino Nano. This one here is a Chinese clone. The serial adapter on it is rubbish, so it doesn't always work, but it does enough to actually make it work. On the other side, there is an MCP2515 module. Once you solder it all together, you get yourself a little CAN adapter. You can then plug that into your car and listen to what's going on. The default sketch I would suggest you install is the one that says listen all. This basically is a dump of what the car is producing out with that basic sketch. Here is it shown in the Arduino serial monitor. Here is it shown in PuTTY using, again, the serial monitor in PuTTY. Details of GitHub is there. There is a second, slightly smaller adapter I have made called the Tiny Can adapter. That is a UK £1 coin for scale, and that little adapter there uses the new ATtiny 1614, which is actually the chip on the left, not the chip in the middle, with a MCP2515 module and a SN65HVD230 CAN transceiver. So it's a slightly smaller version of the NanoCan. There are 2 flavors of this. There are actually 3 flavors of this now. This is the one that can be used for surreptitious funny stuff. You program it with certain messages. If it's a certain sequence, if it sees a certain message, it will set off a certain sequence. And you can play with people's cars without them knowing it's actually there. All a bit of fun, but you could scare someone with it. And this is the alternative version. If you notice, there's a slightly different board, color board in the back, which is green, not blue. This one allows you to plug in the USB to serial adapter, which then means you can run serial line CAN and socket CAN on a Linux box. These are actually powered from the OBD2 port as well. I haven't got around to putting these on, putting the software and or hardware on GitHub yet, but it's one of the things I've got to do probably over the Christmas break this year. I'll do it at some point. But I have actually built another version of the Tiny Can adapter, which will actually go inside the shell of a OBD2 plug. But I've not got any pictures of that in this presentation. So next, here's a video of what I call disco mode. This is using the Tiny Can to squirt in messages on the same bus as the steering controller, the steering switch controller, to make it go into disco mode. That would actually affect both the inside and the outside of the car. I have another NanoCan configured on the other CAN bus, which just does disco dash. Doesn't affect any of the outside of the car, but makes the dashboard light up like a Christmas tree and have an epileptic fit. So yeah, they can be used to play. So that's me done. I'd like to say thanks to the Grim Cyber team, because they were the inspiration and they did actually help me quite a bit in getting some of the things ironed out, like recommendations for power supplies, etc. They are named there. I'm not going to name them. The Kayak Village team in the US, and I'd also like to thank the ROOTCON team for allowing me to actually talk today. I will be in Discord or whichever platform we are using to do questions after this talk. If you have any issues and you want to get in contact with me, my contact details are down the bottom there. As long as you're not asking me to help you with something illegal, I will assist. It's amazing how many people are dumb and try to actually get you to help them with something dodgy. It's not worth it. But I will, if anyone gets in contact and wants a NanoCan PCB, just ask. I will put them in a post. It will cost you the postage. I don't make any money out of it, but it's just me helping others get into hacking. If you want some of the other obscure PCBs that I've had, if you see them online, etc., again, ask, because I've got loads. I always order panelized, so I get too many. So I will send them out to help others. But that is me done for today. Hope you have a great con and probably see you all in the future. Thank you very much.